the chat, or you can use the screen annotation or your mic to state the answer. In the first question, a student investigates the period of a pendulum. Figure 1.1 and 1.2 shows the arrangement. So you can see the arrangement, like students set up this pendulum. And this is like he released from one point, so it moved and then returned back. That will be called as one oscillation. The student measured the distance d between the bottom and of the clamp and the floor. So you can see the bottom of the clamp and the floor, and that distance is 120 centimeter. This distance d remained constant throughout the experiment, so he did not change this distance. He then adjusted the length of a pendulum to be 70. So he adjusted, what is the length of a pendulum? The point where we attach a string to the center of the mass of this bob. The sphere is called a bob. So the distance length from center of mass to the point where we attach the string, that is called a length of a pendulum, denoted by L. And he adjusted that to be 70. Calculate the distance x between the center of the mass of the pendulum and the floor, and record this x in the first row of table 1.1. So if this distance is 120, if this distance is 120 centimeter and student adjusted the length to be 70 centimeter, how much is this length x? What will be length x? If the total length is 120 and the length L is 70, so how much is this length? That's right. So it is equals to 50 centimeter. And this 50 centimeter, in the question they mentioned that this 50 centimeter we have to complete that value for x in table 1.1. So where is table 1.1? This you can see a table 1.1. So the length is equals to 50 centimeter. You don't have to write a unit. And as you can see, in this column, all the values are given to one decimal place. So if I write 50, that is not the scientific way to represent the result. So I should write as 50.0. So the number of the significant figure or number of the decimal places for each column should be same. Because in this column, we are using to one decimal place. That's why I should write to one decimal place as well. The second part, a student displaces the bob and then it releases so that it's showing figure 1.2 shows one complete oscillation of a pendulum. He measures and record in the first row of a table 1.1 the time for 10 complete oscillation, like how much time it takes to complete 10 vibration, that time is recorded. Calculate and record in the first row of table 1.1 the period of a pendulum. Period means time for one vibration. So we know the time for 10 vibration, we just need time for one vibration. So what will be the time for each vibration? Like example, in this column, we have the time for 20 vibrations. We need for one. So to get the time for one vibration, what we'll do, we'll divide the time for 20 vibration. This was not 20, this is 10 vibration. So normally, because in the question they say 20, so I was used to write 20, that's why. But otherwise, 20 vibrations are given in the question. So we want the time period, how to work a time period. So the total time for 10 vibration divided by the number of vibrations. So number of vibration are 10. So that will give us a T. So it is 16.7 divided by 10. So it will get 1.67. And then the last column, it is T square of this. So 1.67 square. That is equal to 2.7889. So 2.788 and 9. But because all of the answers are given in two decimal places, so I have to write in two decimal place. So what I will write as 2.79. Then we have to complete the column heading. What is the meaning of a column heading? Means you have to represent what units we measure these quantities or values. So x, what was the unit of x? That is in centimeter. What is the unit of time? That is second. What is the unit of period or a time? That is also second. And what is the unit of t square? So t square will be second square. Because t is second, so t square will be second square. Then the next part, he repeat the procedure for 45 centimeter and then 40 centimeter and then for 30 centimeter. He records the reading, plot a graph t square on y-axis against x on x-axis. And you do not need to start your axis at the origin. Like, what does it mean? You don't have to start the axis from the origin. It means like, I don't have to mention like 0, 0 here. I can start with any number. So t square on y-axis and x is on x-axis. What are the values of the x? Whenever you're plotting a graph, your graph, the idea is that whenever you plot a graph, you should cover 70% of the graph paper. So as I mentioned, I don't have to start from origin. I don't have to start with 0. I have value from 30 to 50. So if I divide my scale, like example, if I say this is 30 on x-axis, I'm plotting. So if I start with this 30 and I write this as 40 and then 50. So it's about on x-axis, I'm covering more than my scale is actually cover more than 70%. And the label on the axis, it is very important. 1 mark is for just writing the label on the axis. So that is x and then slash, what is the unit of x? Centimeter. So x slash centimeter is on x-axis. Same thing for y-axis. For y-axis, we have t square. It is not important that you draw these lines. I'm just drawing as a reference. So for y-axis, it is t square slash, and what is the unit? S square. But we have to check the scale. We have to check the scale. What is the scale? It is, this value was 2.79 was there. So basically the minimum value is 2.79 and the maximum value is 3.6. So I have to select a scale that maximum is around 3.7 and the minimum is around 2.7. So if I start from 2.7 here, then this is 2.89 because I want from 2.7 to 3.7. So 2.7, 2.9, 3.1, 3.3, 3.5, and 3.7. And what is the last value? If it is more than like 3.71, or it is 3.61, so it is. And why I did not start the graph from 0, 0 or origin, because they already mentioned that we don't have to include the origin, so we can start with any value. And after that, you have to, this one is 35, this one is 45. So what are the values when time is the time square 2.79 was 2.78, this t square is 2.78 for 50. So I have 2.78 on x-axis, each is representing 0.0, on y-axis, each is representing 0.02 because this is 2.7 and in between there will be 2.8. Here this will be 3, 3.2, 3.4, and 3.6. So when it is 50, the value is 2.78. So 50 and 2.78. So 50 is there and 2.78 somewhat here. I'm not exactly trying to mark a point. I just want to have a sketch of a graph rather than accurate. But in exam, you have to be sure that which point you mark according to the values given. Then the second value for 45, it is 2.99. So for 45, it is 2.99 somewhat here. Then the third value at 40, it is 3.2. So at 40, it is around 3.2. Then at 35, it is 3.39. So 3.39 or around 3.4 is there, 35. And then 3.6 is there, 3.61. So these points appear to be in a straight line. So what we will do, we will draw, because we have to complete, so we'll draw a best fit straight line. So this is how we sketch this graph. So it is important that you label the axis, the distribution of the mark. One mark is for labeling the axis. That is one mark. One mark is for selecting a suitable range of a scale. For example, as I select from 30 to 50 and 2.7 to 3.7, that will award you the second mark. Then marking the points, all the points should be marked correctly. That will give you the third mark. And drawing the line of a best fit here, that will give you the fourth mark. So it is important that you label the axis. Like this is a very common mistake student used to make. They just write the numbers, but they don't label the axis. So one mark is for completing the labels for X and Y axis. The next part state whether the graph for t square and x is proportional to x, and give a reason. Look, whenever you have a graph and you want to identify whether two quantities are directly proportional or proportional to each other, what is the condition for a directly proportional graph? It should be a straight line. That is one condition. It is a straight line. But what is the second condition for two quantities to be directly proportional? The second condition is that the line or a straight line should start from origin. So this is a straight line. There is a first condition that the line should be straight. That is the first condition. And the second condition for the directly proportional quantities, it should start from origin. But this is a straight line. It follows the first one, first condition, but it is not starting from origin. So it does not follow the second condition. It means t square and x are not directly proportional to each other. So state whether the graph shows the line of a t square and x proportional. So statement, we will say no, and reason, we will say the straight line is not starting from, does not start from origin. Then explain why the timing 10 oscillations give more accurate result. So why we are not measuring time for one vibration, why we are measuring for 10 or normally like 20 vibration we measure. So because when we measure a time for one vibration, that time interval will be so short that the chance of error is high. So whenever we are making a small measurement, the uncertainty, the percentage error is very high. So why we are measuring time for 10 oscillation or 10 vibration, that is to reduce the percentage error, or we can say uncertainty. Because, like example, the time for one vibration is 1.67. and time for 10 vibration is 16.7. So which time is easy to measure? So this one is easy to measure because a longer interval is there. We can recognize the positions easily and measure the time accurately as possible. Then a student investigate, this is question 2, student investigates resistance. Figure 2.1 shows the circuit he uses. You can see there is a power supply, a switch is there, an ammeter to measure current, a voltmeter to measure voltage, and a resistance, because resistance is the ratio between voltage and current. She records the potential PD across the resistor, that is V1, and the current is I1. The meters are shown in figure 2.2 and 2.3. Write down the reading, include the unit of a potential difference. Potential difference means the voltage or and current or resistance when appropriate in all parts of the question. So first, what is a voltage reading? What is the reading on voltmeter? You can use a mic or a chat to state the answer. How much I should write the voltmeter, reading on the voltmeter? Yeah, what should be the voltmeter reading? Remember, look, each line is representing 0.2, because from 0 to 1 there are 5 lines. So this is, each line is representing 0.2. So this is 2.2 and 2.4. So it is important that you read this instrument correctly. That's a simple way just to identify the smallest mark. The smallest mark is 0.2. So that is right, 2.4 is the correct answer. Then what about an ammeter reading? This, you can see from 0 to 0.2 there are 10 lines. So each line is representing 0.02. So what is the reading on ammeter? It is between 0.4 and 0.
So Mr. 0.5.
0.5. Yeah, this between 0.4 and 0.6. So that is right, 0.50. That's right. The next part, calculate the resistance. What will be the resistance? So we worked out the voltage was 2.4 and the current was 0.50. So we need a resistance R1, which is a ratio between V1 over I1. So 2.4 divided by 0.5. So that will come out as 4.8, and the unit of the resistance is ohm. So 4.8 ohm will be there, the resistance. Paper 6, you don't have to learn any formula. They will provide you a formula. You just have to use and get the final result. Then she connects a second resistor in series with the first one. So there was one resistor in the first part. Now the two resistors are there. Then she connect a voltmeter across both of the resistor. So what she did, now she placed another resistor here. In series to this one. And now the voltmeter is measuring the total voltage. So if this voltmeter is measuring a total voltage and the current is there, so when this voltage divided by current, that will give us a total resistance of these two resistors which are in series, because that is the total voltage divided by total current. So we have to calculate the resistance of two resistors which are connected in series. So V2 is 2.6 and I2 is 0.28. So if 2.6 divided by 0.28, what is the answer for this? That is 9.28. So this one is equal to 9.28 ohm. The last part, the part C, then she connects a second resistor in parallel with the first one. So she changed the circuit now. Before the two resistors, there was one resistance only, then she connect another resistor in series, and now she changed the circuit. Now the second resistor in parallel. So she measures the voltage and she measures the current, and voltage divided by current, she will get the resistance of this combination. So calculate the resistance when they are connected in parallel. Again, V3 divided by I3. So that is 2.4 divided by 0.99. So 2.4 divided by 0.99, that's equal to 2.42. So 2.42 ohm, that is the resistance in parallel. Then complete a circuit diagram to show circuit she used in part C. So here you have to draw the circuit. The same circuit, the only difference what it will make, instead of connecting the resistor in series, there will be another resistor in parallel. You don't have to draw here. You have to draw the circuit in the space which is given. So this place you have to draw the full circuit. Then describe how to extend part C for this experiment to investigate the relation between combined resistance of identical resistor connected in parallel and the number of resistance. So what she can do to investigate how when resistor, what is the combined resistance? What is the combined resistance of resistance in parallel and the number of resistance? What is the relation between them? So how she can investigate that, because she did only once. So what she should do, she should repeat the experiment with different number of resistors or increasing a number of resistors in parallel. And measure voltage current to find the total resistance of the combination. So what she should do, if you want to investigate how the resistors in parallel or total resistors in parallel affected by the number of the resistors in parallel. So for that purpose, you should repeat the experiment using more resistor and calculate the voltage and current for each combination and find the resistance. In this type of experiment, electrical experiment, a variable resistor can be used to vary the current. In a space here, you have to draw a symbol for a variable resistor. So what is the symbol for a variable resistor? It's a rectangular box, and you can draw, there are two ways to draw a circuit symbol for variable resistor. Across means a diagonal is there, an arrow, or you can also draw a rectangular box an arrow representing the movable part. So any one of them you can draw. So better draw this one. So this was May, June 2021 paper 2.